This is a continuation of the test 4 review, and in this part of the review we're going to focus on some implicit differentiation work. So this is from packet page 23, at least it's the correct page number for this particular year I made the video. Problems 2, 9, and 11. So the first one, first problem tells us to find the equation of the tangent line and normal line. So as soon as you read the words, find the equation of a line, the very first thing you should do is write down your target. In other words, what is my answer supposed to look like? What is this problem telling me to do? So once we write down the point-slope form of an equation, we see that we need three things. We need an x number 1, we need a y number 1, and we need a slope. And if I have those three things, I can easily write the equation of a line. Now in this problem, they already told us that the point is 1, 1, so x1 is 1 and y1 is 1. So really the only thing that we have to find is the slope. And because you're in calculus, you know that if we're going to find the slope, we're really just trying to find instant slope, derivative, dy dx. Which brings us to finding the derivative implicitly of this relation. Now the thing I want to warn you about in this problem is what I call the squishy product rule. So right here, before I unveil the answer and walk through that, that's 3 times x times y. That requires the product rule. But with my math eyes, I'm going to see that as 3 times xy. In other words, I'm only going to use the product rule for the product of x times y because 3 is simply a coefficient. All right, so we're taking the derivative with respect to x. So here we go. In step number 1, you can see that, well, that's just the rewrite of the problem. So in step number 1, the derivative of x squared with respect to x, let me grab my pen here, is 2x. And the teacher who did this particular workout used their math eyes to view the problem this way, 3x times y. So they attached the 3 to the x, which is perfectly fine, and they did the product rule with that. So we would have 3x as our first factor and y as the second factor. The derivative of 3x is 3, and the derivative of y is dy dx. So then we're going to multiply first times the derivative of second plus second times the derivative of the first. For the third term, the derivative of y squared is a y term, and there's variable disagreement, so the derivative of 2y is 2y dy dx. Lots of algebra is going to occur. We're going to collect the dy dx terms together. It's not shown here. And we're going to collect the non-dy dx terms on the other side. Be very careful with your algebra. And we get negative 2x minus 3y, which is right here, for the derivative. And remember, we were generating that because we needed the slope, so we're going to substitute the x value of 1 and the y value of 1. And when we do, we get a slope of negative 1. So now I have the third component for the equation of my line. And so the tangent line is going to be y, that's not negative y, that's a straight mark. Y minus 1 is equal to negative 1 times x minus 1. And that can be simplified to x plus y equal to 2, or in our class, you know that we generally have a standard of just simply getting y by itself. So the tangent line would be y equal to negative 1 times x minus 1 plus 1. And of course, you can distribute the negative, you can combine like terms. If this was a multiple choice question, you can manipulate the linear equation to be of any form that you want. Now remember, for a normal line, I'm over here on the left-hand side, for a normal line, a normal is simply perpendicular to a tangent. That's what normal line means. It goes through the same point, so we still have the point 1, 1. And the slopes of perpendicular lines are opposite. That means change the sign, reciprocal, flip the fraction of each other. Now in this case, the slope that we had for the tangent line was negative 1. So if we change the sign, it goes positive 1, and if we flip 1, we get 1. So the slope of the normal line is going to be positive 1. And so there's the normal line. And again, I know that the teacher who did this is a former colleague of mine. The teacher who did this work left their equation in standard form, but we're going to get y by itself for our work. And then over here on the right-hand side, although you wouldn't be expected to produce the graph of the sideways hyperbola, I did want you to kind of visually see what you just accomplished. You have the hyperbola, so that's in blue. That's the relationship that you, or the relation that you see right here. And then the green line, which is right here, that is your tangent line that you wrote the equation of. And the red line is the normal line, which is perpendicular to the tangent line. All right, let's move on to number 9. Number 9 wants us to find the points of tangency of the horizontal and vertical tangents. So bottom line, we are looking for vertical and horizontal tangents. So job number 1, job number 2. I'm going to clear my screen here, my annotations, so I can do some more annotations. And I'm going to move this down a little bit. Okay, so over here on the left-hand side, just a reminder, for horizontal lines, the algebra component, because everything bases on algebra, horizontal lines are y equal to lines, y equal to some number, and the slope of a horizontal line is 0. So once we find our derivative, assuming that we're going to have a numerator and a denominator, in order for the value of a fraction to equal 0, only the numerator can equal 0, because we know by division by 0 is undefined. On the other side, if we have a vertical line, which goes up and down, which is an x equal to, we know that the slope is undefined. And if our derivative is comprised of a numerator and a denominator, then the only way to get that fraction to go undefined is for the denominator to equal 0. So that's the basis of the work we're getting ready to do. But obviously, in order to do anything, we first have to find our dy dx. We have to find our slope so that we can get the vertical and horizontal tangents. So that's your implicit work. Again, with my math eyes, I am seeing a product. I'm going to click the pen. I'm seeing a product of 4xy. Now, again, this teacher will probably do it the same way they did it before, but I think probably it's easier to do 4. View it this way with your math eyes, and then we have x, derivative of x is 1. We have y, the derivative of y is dy dx. And then you can first derive second plus second derive first, and then distribute the 4. All right, let's get rid of that. Let's get rid of the browsers. Okay. So there is and you've already seen these answers in your packet, but there is the algebraic workout, the implicit differentiation going on with the dy dx's. Again, we're going to collect the dy dx terms and the non-dy dx terms and get dy dx by itself. And now we get to the point, no pun intended, where we're finding horizontal tangent. So as we said over here on the left-hand side, we're going to set the numerator equal to 0. Now you'll notice that this teacher, again, it's a math teacher, so they're going to try to simplify their life as much as possible. So right here in the numerator we have, let's write it right here on the right side, negative 2x plus y. I believe that's what that says. No, what does that say? Well, hold on just a second. Okay, so I see what she did. If you come back up to this step right here, there is a 2x that is a non-dy dx term and a 4y that is a non-dy dx term. So the teacher who did this work subtracted the 2x to the right, and let me erase because I have a plus sign. Let's get rid of that. And subtracted the 4y for the numerator. So that's the numerator of our derivative. So then the teacher decided to factor out a negative 2, and that will give you an x plus 2y. In case you're wondering, what happened and why. So the teacher could have just as easily set negative 2x minus 4y equal to 0 and get the same answer when you simplify and reduce. Now, when you're solving for x right here, or solving for, you can choose any variable that you want at this point right here. You can either get x by itself or y by itself. Choose the easy variable. In this case, since x doesn't have a coefficient, it's easier just to subtract 2y to the right-hand side. Now, as you know from our experience in class, we're going to take that negative 2y and we're going to substitute it back into the original. So when we do that, so there's that work right there. So just take a look at the work first. So right here, this is substituting the negative 2y in place of all of the x's. And when you do, you will get a y value of positive or negative 3/2. Be careful when you take the square root that you get the positive and the negative. And then once we get that positive and negative 3/2, we can take that. Let's click my pen here and go to a purple. Once we get that positive and negative 3/2, we can substitute that back into the equation of the line that we found to get the x coordinates. All right, I'm going to clear the annotations so that we can go back and look at the vertical tangents. Clear. And we're going to follow the same process, except for this time we're going to set the denominator equal to 0. And again, you can see that the math teacher who did this work factored out the 4, which is okay. We're not factoring out the 4. You'll get the same thing. X is equal to negative 8y, so we're going to substitute back into the original relationship to get 2y values plus or minus 3/4. And once we get those plus or minus 3/4, be smart. Take those and substitute, so there's the plus or minus 3/4, substitute back into the equation of your line to get the corresponding y values. And this relationship is actually graphically an ellipse, so I just wanted you to see, what did you just do? You showed or found the points of tangency. So up here, there is a horizontal tangent at this is negative 3, positive 3/2, and you can see visually that agrees. And down here, this is the horizontal tangent, positive 3, negative 3/2, and then likewise for the vertical tangents. So looking at number 11, we don't have the workout here, so I'll work this one out, and we are looking for the second derivative. Obviously, to get to the second derivative, we have to find the first derivative. So I'm going to do that here. The derivative of 3x squared with respect to x is 6x. The derivative of 5y squared is going to be 10y dy dx. There's my chain rule. And the derivative of 15 is 0. Isolating dy dx would give me subtracting 6x and dividing by 10y. And I can divide that or reduce the negative 6 over 10 by 2, which will give me negative 3x over 5y. So that's my first derivative. For the second derivative, I'm going to need the quotient rule. So second derivative will give me down 5y, d up is negative 3, minus up, which is negative 3x, d down will give me 5 dy dx over down, which will be 5y quantity squared. Cleaning that will give me negative 15y, and then this negative times this negative makes a positive 15x dy dx over, I'm going to go ahead and square that and make it 25y squared. Now, we know that dy dx represents the first derivative, which we have right here. So we're going to substitute that into the dy dx, which will give me negative 15y plus 15x. Here's my substitution of the first derivative, negative 3x over 5y. just a substitution, over, whoops, sorry, that's a little not straight, 25y squared, which is equal to, just cleaning up the algebra, so 5 divides into 15 3 times, and 3 times negative 3 is negative 9x over y. And so now I can see I'm going to need a common denominator, so I'm going to put that over 1, and that's over 25y squared. The common denominator of the numerator will be y, so this is what's happening here, over 25y squared over 1. Multiply numerator denominator by y, that'll give me 15y squared minus 9x minus 9, oh, I noticed back here I made a mistake, x times x is x squared, glad I caught that, x squared, which is the same thing as negative 15y squared minus 9x squared over y, multiply by the reciprocal, that'll give me 1 over 25y squared, which is negative 15y squared minus 9x squared over 25y cubed. Now there are some things that we could do here. For example, keep your eyes back up here. We know that 3x plus 5y squared is equal to 15. I could actually factor a negative 3 out of the numerator and make that into 3x squared plus 5y squared over 25y cubed. If this was a show your work part of my test, you wouldn't necessarily have to do that. I guess it could be a multiple choice item where it could be kind of tricky, because now, since I know that 3x squared plus 5y squared is equal to 15, I can substitute that and make this negative 45 over 25y cubed, and then I can reduce that by 5 and make that negative 9 over 5y cubed. So that's number 11. All right, now let's look at page 8, which is more chain rule work. So back to the chain rule, and those answers are posted for you, but I'll just talk a little bit about those. So in problem number 2, remember this is all about math eyes and what you see. So we're looking at problem number 2. And hopefully you see, first of all, a product, the multiplication of x times e to the tangent x. So we're going to have our product rule, and our two factors are x and e to the tangent x. The derivative of x is 1, and the derivative of e to a power is e to the power times the derivative of the power, and the derivative of tangent is secant squared x. And then I'm going to do the first times the derivative of the second plus the second times the derivative of the first. And so I'll get x times e to the tangent x secant squared x plus e to the tangent x. Moving on to number 5. So with my math eyes, and that's really, the first thing is identifying what you have. Don't just jump in and start working. Just figure out what you have. So hopefully with your math eyes in number 5, you see a quotient, numerator divided by denominator. Yes, I could make it a product and move the x squared to the numerator and make that x to the negative 2 multiplied by sine 5 minus x. I don't see that would be tons easier. I'm pretty sure, I don't even know what I'm going to say when I move the screen down. I don't know if I'm pretty sure I did it as a quotient, because that's what I'm thinking I would do right now. So let's see if I agree with myself. Yep, I did the quotient rule. So in this problem, get the pen. So I did down, d up. Now right here where you have sine of 5 minus x, be really careful. That needs the chain rule. The outside function is sine, and the inside function is the angle. The derivative of sine is cosine of the angle. That's the derivative of the outside. multiplied by the derivative of the inside. So the derivative of the inside is -1. Be really careful. It's easy to mess that up. And so that's why, so I didn't make a mistake with my trig. You might be, uh-oh, Mr. Jernigan made a mistake with his trig. No, the negative is not me incorrectly taking the derivative of sine. It's taking that -1 and multiplying it to the front. So that's down the up, and then minus up. So there's the up, and the d down is 2x over down, down. And as far as cleaning, I just dropped parenthesis on the first term. That's about all I did for my cleaning. And that's really all you would need to do. Number 6, let's go get our math eyes and take a look at what we have there. In number 6, I see ln of something, so that makes me think ln of u. The derivative of ln of u is u prime over u. In this case, u is equal to the cosine of t, now t is my variable, over k. K is to be treated as a constant in the directions at the top. It tells us a, b, and k are constants right back up here. So a, b, and k are constants, and so you're going to treat a, b, and k just like you would the number 5, your AP score, and so that's just a good way to remember that when you get to those constants. So another way to look at this, I'm going to bring this back down, is I would do a little rewrite here and say u is equal to cosine of, and we've talked a little bit about this in class, 1 over k. In other words, that is a coefficient times t. So when I take the derivative, so the u prime, you got to be really careful. This is the outside, this is the inside. So the derivative of the outside is negative sine of the angle, 1 over k times t, and then the derivative of the inside, right here. So like I said, come on over on the right-hand side, that's kind of like having 1/5 t. The derivative of 1/5 t is 1/5. So likewise back over here, the derivative of 1 over k times t is 1 over k. So I could rewrite that to be negative sine of, I can put that back into t over k, or I don't have to, over the k. So u prime over u. So this is the u prime right there, and then that's going to be over u, which is right here. So let's see what happens. Number 6. Come on. There we go. So in number 6, I have u prime. There's my negative 1 over k sine t over k over u, which is cosine t over k. Now, look right here. Sine, come on, give me a pen, blue pen. Sine over cosine is tangent, and we have the same angle, and then there's my negative, and I can just make that over k. All right, let me clear these annotations, get them out of the way, and let's go to problem number, oh, I did not mean to do that, so let's just reset the page, because I got rid of all my other work. Problem number 9. Slide this down. Let's make some more room here. All right, problem 9 with my math eyes. Let's see what I see. So I see a trig function, I see an outside function of a power of 100, and I see an inside angle. So this chain has 3 links in it. I've numbered those for you. The first thing I'm going to take care of is the power rule. The second thing is the trig. And the third thing, please don't forget the angle. So when I take the derivative, let's uncover that. You will see that, a different color here. I'm going to take the 100 using the power rule. So there's the 100. Decrease the power by 1 of 99. Leave the inside alone. So the cosine of t squared, this just comes right along. So all of that whole expression right there is me doing the power rule. That's the first step. Then the next step that I'm going to take care of is the derivative of cosine, because that's my inside function, and the derivative of cosine is negative. There's my negative right there in case you're wondering. Negative sine of the angle. Leave the angle alone and bring it along. And then lastly, the derivative of the angle is 2t. So in cleaning up, I can multiply the 2 times the negative 100, which is what I did there. I can or cannot, it's up to me, drop the brackets around and put the 99 onto the cosine. So that's just some ways we could rewrite that. I think I have more. What else do I have here? Maybe that's all. Maybe that's all of those. Well, let's turn the page and see if we have anything else here. Oh, yes. Oh, yes. So, number 11, math eyes. Math eyes, math eyes. All right, there's number 11. I see ln of e. That triggers my algebra. ln of e. We know that ln and e are ln of x and e to the x are inverses of each other, meaning that they undo each other. So in this case, the ln and e are going to undo each other, and what this really boils down to is that y of t is equal to a t squared minus b. Now remember, we were told in the directions that a is a number like 5, your AP score, b is a number like 5, your AP score. So when we take the derivative, so if we think of it like 5t squared minus 5, that would be easy to take the derivative of. So we're going to use the power rule and the constant rule, and we simply get 2at. Moving on to number 15. So for the year that I'm making this video, 2020, 15 is not on your test. It's a variable to variable situation. And finally, in number 17, directions are find dy dx. So with my math eyes, when I look at number 17, I see two variables right here, which tells me I'm looking at, come on, you can do it, which tells me I am looking at an implicit situation. So I also see a product going on in there. So I have x times y. Derivative of x with respect to x is 1. Derivative of y with respect to x is dy dx. So when I need the product rule, that's already set up for me. So let's take a look at my work. So I'm going to start with the derivative of cosine. Let's see, where does that work go? I already did, that's 15. So right here in number 17, the derivative of cosine is, sorry, just grabbing my pen, is negative sine of the angle times the derivative of the angle. There's my product rule work. First derivative second plus second derivative first. On the right-hand side, the derivative of x is 1. The derivative of 2y is 2 dy dx. Now, we talked about in class, what are we going to do now to unlock? Right here, we have a dy dx that's quote-unquote locked inside of parentheses. Well, that means we're going to have to take this first factor of negative sine xy and distribute it into the parentheses to unlock the dy dx. So that's what I'm doing right here. So negative sine xy times x dy dx, that's what gives me the first term. So that's distribution of the first term, distribution of the second term. On the right-hand side, I left everything alone. That allows me now to get the dy dx terms all on one side and factor, and the non-dy dx terms on the other side, and then divide by the that factor times dy dx. And there's really not much I can do to clean that up. And then lastly, number 19 is asking us for the second derivative. Let me move this down just a little bit. So to get to the second derivative, I have to find the first derivative. In doing that, the derivative of x squared is 2x, and the derivative of y squared is 2y dy dx. Get dy dx by itself, divide, simplify, and I get x over y. Quotient rule, down d up minus up d down over down down. So when I do the quotient rule, there is the down, d up. Oh, sorry, down d up minus up d down over down down. You know that dy dx represents the first derivative, and the first derivative is here, x times y. So I can substitute the x times y in there, and that's what I did right here. X times x makes x squared. The y needs a denominator of 1, so I can get a common denominator, and there that is. This y squared is just being carried over from the what I'll call the grand denominator. So I'm going to get a common denominator in the numerator of a y. Oops, it goes sideways. All right, so let's go up. Sorry, turn your head sideways. So, pen, red, there we go. So the y squared is there. The common denominator in the numerator is y, so that's what's happening right there. And then this is y squared over 1, so I can multiply by the reciprocal to get me to y squared minus x squared over y cubed. I can you don't have to do this. If you got it to y squared minus x squared over y cubed, I'd be happy, but I'm showing you that you could factor out a negative, and when you do, it takes you back to x squared minus y squared, which is 8, so I could substitute that back in. All right, so that's the second part of your review for test number 4.